Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to talk about inverse variation. Alright.
Okay, so now let's talk about inverse variation. So for inverse variation, you will encounter this statement or this phrase, y varies inversely as x. Now in this case, we have two variables given. We have the dependent variable and we have the independent variable. So again, the word varies inversely can be translated changes due to the value of the independent variable. So the dependent variable will change due to the value of the independent variable. So this will be translated as y is equal to k over x. So the difference between direct variation and inverse variation is the operation between the constant variation and the independent variable. In inverse variation, we have division. And let's have an example of an application of inverse variation. So for example, we're given a rectangular garden that has an area of 36 square meters. The following are some of the possible dimension of the garden. If I'm going to ask what will be the dimension of a 36 square meter garden, we will have different possible dimension. So we will have, for example, 1 by 36 dimension of the garden. We can have 2 by 18 or 18 by 2. We can have 3 by 12. We can have 4 by 9. Or we can have 6 by 6 dimension of our rectangular garden. Let's place that in the form of a table of value. The formula for the area of a rectangular garden is length times width. Let our width be equal to our x and our length will be equal to our y. Now, looking at this, our area is all 36 square meters. We cannot increase the area of our garden because it is given. Okay, next is our width. So if we have a width of 1, the length will be 36. And if we have a width of 2, if our width is 2 meters, we will have a length of 18. Width is 3 meters. We will have a length of 12. So to get the length, we just simply divide 36 by our width to get the length, which is 9, and so on and so forth. Okay, now what can you observe about the relationship of the width and our length, our x and our y? So our constant variation here will be the area because our area will still be 36 whether we change our dimension. So our constant variation for an inverse is the product of x and y, the product of our independent and dependent variable. Now, let's talk about the relationship of x and y. Okay, if you can observe, if x increases, our value of y decreases. And that is the relationship of our inverse variation. If x increases, our y decreases. If x decreases, our y increases. Okay, so now let's have our examples in solving inverse variation. Okay, so let's have an example. If y varies inversely as x and y is equal to 6 when x is equal to 4, find y when x is equal to 8. So first thing that we can observe here is the use of the word varies inversely. So we're going to have our equation y, our dependent variable, be equal to our constant variation over our independent variable, which is x. Now, after that, we will now prepare our table of values for our given. Take note that they have a pair of x and y. So since we are given the variable y and variable x, and since they are a pair of dependent and independent variables, we're going to write our given in form of a table of value. So for our given, we have y is equal to 6 when x is equal to 4. Now we're looking for the value of y. Okay, we're looking for the value of y when x is equal to 8. Now, in order for us to do that, we must get the constant variation. In order for us to get the constant variation, we must multiply both sides by x. So we will have a formula of the constant variation being equal to the product of our independent variable and dependent variable. So in this case, 6 times 4 is equal to 24. So that will be our constant variation. Since our constant variation is 24, it will be the constant variation of all the pairs of x and y in this problem. So we have 24 as our constant variation. Now let's proceed to getting the value of y. To get the value of y, we will still use the same equation, which is y is equal to k over x, and substitute the given. We will have y is equal to 24 over 8. So let's divide 24 divided by 8, and that will be equal to y is equal to 3. Y will be equal to 3 when x is equal to 8. Alright, let's have another example. For example, if a varies inversely as b and a is equal to 12 when b is equal to 8, we're looking for the value of a when b is equal to 3. So in this case, we're going to focus on the phrase varies inversely. So we're going to deal with inverse variation, and we will have an equation a equal to k over b. And then after that, we can now set our table of values for our given. We have a and b. So for the first pair of a and b, we have a is 12 and b is 8. So 12 and 8. And for the second pair, we're looking for a. When b is 3. So in order for us to solve for the value of a, we need to get our constant variation. Okay, so we need to get our constant variation. And to get the constant variation, we need to multiply both sides by b. So we have k is equal to a and b. Take note, the constant variation for our inverse variation will be the product of dependent and independent variable. So in this case, we have 12 times 8. That will be equal to 96. All pairs of a and b will have a constant variation of 96. Now, let's proceed to solving our value of a when b is 3. So, we will use the same equation, a is equal to k over b, and then substitute our given. So, we have a is equal to our constant variation, which is 96, over our value for b, which is 3. 96 divided by 3. So 96 divided by 3, we will get a is equal to 32. And that will be the value of a when b is equal to 3. Alright. Okay, so let's have another example. So for example, if d is inversely proportional to the square root of x, and d is equal to 12 when x is equal to 36, find d when x is equal to 16. Now in this case, we use the word inversely proportional. So if you encounter the phrase inversely proportional, okay, it is the same as the phrase varies inversely. So in this case, since we will have an equation d is equal to the constant variation over the square root of x. Ayan, because it's stated there that we have the square root of x. Then after that, we're now going to identify our given by placing them in our table of value. Ayan, so we have d and x. For d, we have 12, x is 36, and we're looking for the value of d. when x is 16. So now, in order for us to solve for the value of d, we must get the constant variation. So our constant variation is the product of our dependent variable and our independent variable. Take note that our independent variable is the square root of x. We need to substitute this given. So we have 12 times the square root of 36, and the square root of 36 is 6. So 12 times 6 we have 72, and that will be our constant variation. So since our constant variation is 72, and the constant variation of all d and x will be 72. Now let's solve for the value of d. In order for us to solve that d, we will use the same equation. D is equal to k over square root of x by just substituting all the given. So we have d is equal to 72 all over the square root of 16, and the square root of 16 is 4. So 72 divided by 4, the value of d will be equal to 18, and that will be our final answer, or that will be the value of d when x is equal to 16. Alright.
Now that you already know how to solve inverse variation, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video.